This video provides practical tips and technique for performing a conductivity probing of a reverse osmosis or RO pressure vessel. The purpose of probing a pressure vessel is to identify where in the pressure vessel an increased salt passage problem is located. High conductivity could be due to an O-ring problem, a cracked interconnector, a cracked end cap adapter, or a membrane element problem like a blown glue line. The goal during a probing is to test the conductivity at the ends of the first and last membrane elements, in the middle of each membrane element, and at the interconnectors where the two membrane elements touch. Before probing, it is beneficial to create a probe sheet to be used in the field. The probe sheet should include the date, RO unit, pressure vessel number, the initials of the technicians doing the probing, the feed water flow direction, the permeate flow direction, the location of the interconnectors and end cap adapters, the locations of the middle of the membrane elements, and lines to record conductivities from each location. Also, in preparation for probing, a probing valve should be purchased or made and installed on the pressure vessel to be probed. The purpose of the probing valve is to maintain as close to actual operating conditions during the probing as practical, and to minimize water splashing on nearby equipment. If there's any electrical equipment that could be hit by water during the probing, it must be protected. A measurement is required from the probing tubing insertion point to the leading edge of the first membrane element. The steps are: remove the end cap that has the probing valve, measure from the leading edge of the membrane element to the end cap, measure the width of the end cap, then measure from the end cap to the insertion point. Add up the measurements. In the example shown, the three measurements were: measurement 1, 4 1/4 inches, or 10.8 centimeters. Measurement 2, 3 1/4 inches, or 8.3 centimeters. And measurement 3, 1 3/4 inches, or 4.5 centimeters. In this example, 9 1/4 inches, or 23.5 centimeters, is the distance from the insertion point to the first membrane element. Membrane elements are typically 40 inches or 101.6 centimeters long, so it's easy now to calculate the distance from the insertion point to the middle of the membrane elements and to the interconnectors between the membrane elements. Calculate the distance from the insertion point to the end of the last element. Mark the probing tubing with tape or a marker. Also, in preparation for probing, the conductivity meter to be used should be calibrated before each probing, using the calibration procedure specified by the conductivity meter's manufacturer. This includes using conductivity standard solution that is close to the conductivity of the permeate being measured. For example, if the permeate conductivity is around 10 microsiemens per centimeter in the first stage and 20 microsiemens per centimeter in the second stage, a conductivity standard solution between 10 and 20 microsiemens per centimeter would be perfect. A conductivity standard solution of 700 microsiemens per centimeter would not be appropriate for this measurement, though it may be appropriate for the feed water and concentrate streams. We are now ready to probe. The steps are: shut down the RO unit. Insert the probing tubing all the way to the end of the last element. Start the RO unit and allow to operate until stable, 5 minutes or more. Allow the permeate to flush the tubing for 30 to 60 seconds. Using a calibrated conductivity meter, fill and dump the conductivity well 3 times, then fill the 4th time and take the conductivity reading. Pull back 20 inches, flush 30 to 60 seconds, and take the conductivity measurement as before. Repeat pulling back 20 inches, flushing, and taking the conductivity until all areas are covered. Because of the interconnectors, it is sometimes a challenge to push the tubing in. Twirling while pushing in the tubing will usually work. If impossible to push in, try new tubing. Analyze the results of the probing and take appropriate corrective actions if required. Wherever the conductivity is the highest, that's where the problem is. Keep the probe data sheets in a hard copy and/or electronic format for future reference and troubleshooting. For much more information on probing and many other water treatment topics, you'll find the best online, classroom, and hands-on training at www.dhptraining.com.